You can do it if you believe you can. Hi, everyone. My name is Mr. Hung, and this is the Unit 3 Exponential and Logarithmic Functions Challenging Problems. Let's begin. Number 1. Simplify 4 to the power of log of base 4 of 64 plus 10 to the power of log of 100. Now, if we really think about the first part, I can just copy 4 to the power of log of base 4 of 64. And if you think about the second part, 10 to the power of log of 100, that is the same as saying log of base 10 of 100. Now, we talked about the 7 or the 8 different properties of logarithmic functions. So, really, you can use it and you can just write down this is going to be 64 plus 100, or it's going to be 164. So, this is what I called logarithmic property number 8. But just in case you're thinking, I don't get it. What's going on here? Can you show me a different approach? Can you give me a little bit more? Of course. So I'm going to draw a little arrow here. And if you like, you can rewrite this as 4 to the power of log of base 4 of, think about 64 as 4 to the power of 3. Now, what that means is we can bring the exponent to the front in a moment. Likewise, if you think about log of base 10 of 100, 100 is 10 to the power of 2. So again, you can bring the exponent to the front. This means this is going to be 4 to the power of 3 of log of base 4 of 4 plus 10 to the power of 2 times log of base 10 of 10, and in a slightly different color. This is basically 1. Likewise, log of 10 of 10 is going to be exactly 1. And very quickly, you will discover 4 to the power of 3 goes back to 64. 10 to the power of 2 goes back to 100, which means the final answer is going to be 164. Again, you can always grab your calculators and double check. That works as well. Let me show you that quickly. So you go back, right? And in a different color, I'm going to write down DC. Now, again, I'm not forcing you to double check. I'm simply offering this idea of double checking using your calculator. So what I do is I grab the calculator and I press 4 to the power of log of 64 divided by log of 4. Likewise, 10 to the power of log of 100. And look what happens. I'm using my calculator right now. I hope you're going to turn it on, press clear, press 4 to the power of log, makeshift brackets, log of 64 divided by log of 4, and I'm adding 10 to the power of log of 100. And of course, I get 164 in the display, which final confirms I'm doing it right. So that's the best feeling I can offer for you, everybody. You show all the steps, but you can also double check with your calculator in less than 1 minute. We are making progress. Question number 2. State which of the following or which of the values in the transform function f of x equal to 2 times log of, open bracket, negative 1 divided by 4, open bracket, x minus 1.5, closed 2 brackets, plus 5 must be changed, and what they must be changed to so that the resulting function has an asymptote of x equal to 6 with the curve of the graph to the left of the vertical asymptote. So again, step 1, draw a diagram. If you really think about this, you're basically thinking about the graph exactly to the left of x equal to 6. So again, in a different color, if I start with the vertical asymptote, x equal to 6, I'm expecting the graph to be somewhere here. So I'm drawing a circle, just saying that this is where the graph is going to be located. So what that means is you go back and you think about the function. You think about f of x. You think about 2, which is the vertical stretch by a factor of 2. That could stay the same. Log you can copy. This negative sign is exactly what we're looking for, because that negative sign really means it's going to be a reflection with respect to the y-axis, or really eventually, it's going to be on this side of the graph. So that's a good sign. We want that negative. Again, that means there's a reflection with respect to the y-axis. Now, if I go back to the first color, again, the 1/4 really means horizontal stretch by a factor of 4, and that's fine. We can leave it as is. Now, what happens is this middle part, which I'll come back to. Again, the plus 5 just means vertical stretch, or I should say vertical translation, 5 units up, and that's fine as well. the key is right here. You're looking for the vertical asymptote to be x equal to 6. This means x minus 6. So I would say, and I'll highlight this for you, this is the one change that you would like to make. So the question again says, state which of the values, right? So the value would be this value right here. This is the value that you want to change in order for this to take place. So you're changing it, right? So change, and we had 1.5 to 6. And by making this one change, the graph is going to be to the left of x equal to 6. Again, if I want to sketch this graph, again, without really giving you too many points, without going through the mapping rule, the graph is going to, roughly speaking, look something like this. So let me go back to the same color for you. It's going to look something like that. Again, I haven't graphed all the points with the mapping rule, but that's roughly the sketch. Question number 3. Again, let's switch colors for you. Let's move on to number 3. Use the properties of logarithms to express the logarithm below in terms of log of base 2 of A, log of base 2 of B, and log of base 2 of C. Your final answer should fully expanded. So again, no problem. Here is how you think about this. I'm going to grab this and I'm going to write it in this space. So I want to give you as many steps as possible. Again, feel free to skip 1 or 2 steps if you understand this, but I want to make sure that we create an inclusive classroom. You matter, and of course, you count. I'm just going to copy the question for a moment here. There we go. Okay. Are you ready? Step 1. Think about the square root. This is the same as expressing it in brackets to the power of 2. I'm going to copy everything inside. So again, I am showing you a lot of baby steps, and I fully recognize some of you would say, this is awesome. Others would say, can you go faster? And you decide how many steps you want to copy down to maximize your skill sets. Now, here's the next step. And of course, I'm going to bring the half to the front. So that's all I'm doing. Everything else, I'm going to copy. Now, as you continue here, you want to expand this a little bit and think about the product law, think about the quotient law. We just, demonstrated the power law. So what I mean is I can express this and say, well, isn't this log of base 2 of, again, maybe I'll show you one more step before we get to that. If you think about the fourth root of b cubed, that's the same as putting this in brackets to the power of 1 divided by 4. I copy b to the power of 3. I'm still copying c. I'm still copying 4 in the denominator. The square root of a is a to the half. So again, I'm just rewriting it in exponent form. Here we go. I put the half, put the big bracket just like that. Now let's kind of, again, do this in a methodical way. I'm thinking about the top and the bottom. So I grab log of 2. I copy this. So b to the power 3 over 4 c minus log of 4 a to the power of half. So notice I'm practicing the quotient law. When you're dividing, you can just write it as log of the first part minus log of the second part. Now I copy this final part minus log of 4 a to the half, and I'll come back to this. We need to simplify that for sure. But if I look at this part right here, and I'll highlight this in yellow for you, this is the same as saying log of base 2, and I should put base 2 for you guys, of course. This is going to be b to the power of 3 over 4 plus log of base 2 of c. So again, all I'm doing is I'm applying the product law, just like that. I go back to the power law in a moment. So again, the half I'll expand at the very end. Right now, notice this exponent, 3 divided by 4, could be brought to the front. So 3 divided by 4 times log of base 2 of b, plus I copy log of base 2 of c. This is the part you want to really mentally lean forward. You want to think about this. I cannot bring this to the front yet. What I need to do is think about this as a square root. So for example, a to the power of half is a to the power of half. But think about 4. Isn't that the square root of 16 or 16 to the power of half? Now this exponent could be brought to the front. And that's exactly what I'm going to do in the following step. So again, half times, and I'm going to copy everything else. And you don't have to copy every single step, but I am showing you maximum number of baby steps. Half times log of base 2 of 16a. And again, we're going to come back to this as well in a moment, okay? Now, look what happens when I expand this. I can expand it now. I can expand it after. You know what? Let's expand this at the end. So again, I am doing this with you live, right? This is how you know I'm showing you every step. I'm copying. Now think about this last part. I'm applying the product law again. So when you think about this, open a bracket, log of base 2 of 16 plus log of base 2 of a, right? Here we go. Now we're almost ready. Almost ready. I'm not going to expand this yet. I'm still going to copy. Now, for some of you, going to say, why couldn't I expand this 3 steps ago? When I get the answer? Yes, you would. And I'm just showing you kind of the logic that I'm demonstrating right here. So again, here's the last piece, log of base 2 of 16. Some of you will look at this and say the answer is 4. But I want to make sure no one's left behind. 16 is 2 times 2 times 2 times 2, 2 to the power of 4. I bring the 4 to the front. Now we're making progress. Look at this, right? 3 divided by 4, log of base 2 of b, plus log of base 2 of c. Now I'm going to bring the 4 to the front. And I think I'm now ready to expand everything. So again, look what happens. Log 2 of 2 is 1. And now when I expand everything, this is going to be half times, and I should put the arrows here for you. Let me switch colors. Again, always use the arrows. Feel free to use them. They're there to support you, right? So I go back to the same color. Half times 3 divided by 4 is going to be 3 divided by 8, log of base 2 of b, plus half times log of base 2 of c. When I take half times half, that's going to be 1 divided by 4. I'm going to keep the bracket here for now. 4 plus log of base 2 of a. Now watch this final step, right? I want to express everything in sequence. So I am going to keep the 3 over 8 log base 2 of b. I am keeping half log of base 2 of c. But look what happens when I expand this. Let me go back to the same idea of using the arrows. Negative a quarter times 4 is negative 1, which I'm putting at the end. And that negative a quarter, log of base 2 of a, which I'm putting at the front. So I believe this is how you do it. And you're expressing it in terms of log of base 2 of a, log of base 2 of b, and log of base 2 of c. Okay. Question number 4. State the transformation that take the graph of f of x equal to log of base 4 of x to the graph of g of x, which is log of base 4 of x cubed minus log of base 4 of 8. Justify your response algebraically. No problem. Now, here's the first step. Again, when you think about this, I'm just going to copy it right here. Let's find a space, actually. Let's do it there. Okay. So I'm starting with g of x. And this says log of base 4 of x to the power 3 minus log of base 4 of 8. So you really want to think about this in a slow and methodical way. Apply the quotient law. So that's going to be log of base 4, x cubed divided by 8. Now that's the first step. And now what you have to do is look at this and kind of say, well, can I express this in a slightly different way? Because I don't want this x to the power 3. That's not going to be meaningful. I'm looking for x on its own. So by inspection, if you think about this, here comes the optical illusion. I'm zooming in to make you feel like this is easier. It's just really just zooming in. And x divided by 2 to the power 3 will give you x cubed divided by 8. Now, why am I doing this? Because when you bring the exponent to the front, g of x equals to 3 log of base 4 of half times x, or x divided by 2. Either one is fine. The question says state the transformations. So I would say the first transformation, remember, it's reflected, stretch it, and move it. So the first one I would say is a vertical stretch by a factor of 3. Let's write this down. The second transformation will be that half in front of x. So this would be a horizontal stretch by a factor of 2. Let's write this down. Horizontal stretch by a factor of 2. That's it. That's how you state the transformation in words, and we solved it algebraically. Question number 5. Solve for x, and there's part A and part B. Again, let's start with part A. Let's see if I can solve it right here. Let's switch colors for you, just like that. Okay. Now, when I think about this entire expression, one method I would like to show you is substitution, right? Let a equal to 5 to the power of 2x. This makes the entire question a lot simpler to understand before you factor and solve and so on. So what this means is if I think about part A, this is 2 to the power of 5 to the power of 2x in brackets cube. So think about power to a power. You multiply the exponents, 2x times 3, it's going to give you 6x. Same thing here, 5 to the power of 4x is 5 to the 2x squared. Again, 2x times 2 will give you 4x back. Again, 5 to the power of 2x, I can copy as is. And of course, I can copy everything else. Now, since I'm saying a is going to be equal to 5 to the power of 2x, this is a lot simpler by rewriting it as 2a cubed minus 9a squared plus 13a minus 6 equal to 0. Now, again, remember, if you can do this without letting a equal to 5 to the power of 2x, that is perfectly fine, right? So what I would say is, in this case, let f of x equal to this left-hand side, right? So again, I'm just letting it equal to 2. And maybe I shouldn't let f of x, let me rephrase this, now that I'm doing it live with you. I'm going to say let f of a equal to 2a cubed minus 9a squared plus 13a minus 6. Think about unit 1, polynomials. Think about the factor theorem. So I'm looking at the factors of 6, and I'm going to grab f of 1. This is going to be 2 minus 9 plus 13 minus 6. Now, if I'm doing this with mental math, that's negative 7 plus 7, which is exactly 0. This means a minus 1 is a factor. I go back to dividing, and I hope you remember there are two ways to divide. There's the long division method, or my favorite method, the shortcut, synthetic division here. So that's going to be 2, negative 9, 13, and negative 6. I put a 1 at the front. I copy. I multiply. I add. I multiply. I add. I multiply. I add. The fact that the remainder is 0 signals to me that I'm doing it right. I go back. What is the quotient? 2a squared minus 7a plus 6. Think about grade 10 math or grade 10 academic math. If we factor this is going to be 2a minus 3. That's going to be a minus 2. So the entire expression that we're trying to solve here equals to, therefore, 2a minus 3 times a minus 2 times a minus 1 equals to 0. Now to solve this, I can divide this into 3 different columns. And in the first column, 2a minus 3 equals to 0. In the second column, a minus 2 equals to 0. In the third column, a minus 1 equals to 0. Now I'm going to start with the last column first. A is going to be 1, but don't forget, a is 5 to the power of 2x. And 1 is 5 to the power of 0. Same base, equate the exponent, x is going to be 0. I go back to the second case, a is going to be 2. Remember, a is 5 to the power of 2x. You go back and you're thinking, how do I solve this? They don't have the same base. Well, log both sides. Bring the exponent to the front. This means 2x is going to be log 5, which equals the log of 2. Again, I would prefer if you leave it in exact form. The opposite of multiplying by 2 log 5 is to divide by 2 log 5. So I would say the final answer, x equals to half, times, and again, thinking about change of base, log of base 5 of 2. Now, if you want to take the calculator around this, I'll leave that to you, but that's the exact form. 2a equals to 3. This means 2a equals to 3, or a equals to 3 over 2. Again, a is 5 to the power of 2x, which equals to 3 over 2. What do? Log both sides. Now again, I bring this to the front, right? Don't forget the brackets. And when you bring the exponent to the front, 2x log 5 equals to log of 3 over 2. Now for some of you, you're going to say, can I write down 1.5? Of course, and we'll honor that here, just in case you're thinking in terms of decimals. The opposite of multiplying by 2 log 5 is to divide by 2 log 5. So I would say, again, the answer here is going to be half log base 5 of 1.5. And of course, you can write down 3 over 2. using the change of base. Now, I'm not going to pick up the calculator and double check this one, but I believe this is right. And if it's not correct, you can comment below or you can contact me. All right. We are making progress. Where are we? Back to 5B. Okay. Now, 5B, again, I'm going to grab this and bring you to this other space right there. Okay. Log of 2 of x. What's the next one? Log of base 4 of x. Log of base 8 of x. Log of 16 of x equal to 25. Okay. No problem. Let's do it. So I would say, again, use the change of base. So step 1, think about this as log x divided by log of 2. Think about log x divided by log of 4. Same idea. Think about log x divided by log of 8. Think about log of x divided by log of 16, which equals to 25. Now think about everything we've mentioned from before. And again, I am becoming a little bit messy here. Thank you for being flexible. Think about the common base, which is going to be 2. So I'm grabbing that common base, and this will help you break down the left-hand side. Why is that? Because you can factor log of base 2 of x to the front, which equals to 25. Now again, the first term is going to be 1 over log 2 of 2, which is basically 1. If you think about 1 divided by log of base 2 of 4, that's basically 2, but I'm going to show that to you again in a moment. And here, that's going to be 1 divided by log of base 2 of 8, which is really 3. Again, running out of space. Let me try again. And here, this is going to be 1 divided by log of base 2 of 16, which is really 1 over 4. So again, just in case you didn't catch that, here's how you do it. Think about it in terms of the following perspective. Log of base 2 of 4 is log of base 2 of 2 squared. You can bring the 2 to the front. Same thing here. Log of base 2 of 8 is log of base 2 of 2 to the power of 3. And log of base 2 of 16 is 2 to the power of 4. And now look what happens. This is equal to log of base 2 of x. This is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, which equals to 25. Here comes a little bit of mental math. Again, you can verify if I'm doing this right with a calculator. I hope my mental math is still passable. The common denominator is going to be 12. So this is going to be 12 divided by 12 plus half is 6 divided by 12. 1/3 is 4 divided by 12. A quarter is going to be 3 divided by 12. That looks like it's 18 plus 7, which is 25 divided by 12. Log base 2 of x equals to 25 divided by 1. The hard part is now over. Cross out the 25. You're dividing both sides by 25. You can also multiply both sides by 12. Now you go from logarithmic form to exponential form. X is going to be 2 to the power of 12. Again, I think this is 4,096. You can grab a calculator and verify this. We are almost there. Number 6. Solve for A and B given the following information. Now, let me copy this somewhere. We're finishing strong, everybody. We're finishing strong. Root A plus root B equals to 8. What is the other one? I'll put it in 2 different columns. Log A, log B. Let's try again. Log A plus log of B equals to 2. Okay, no problem. All right, great starter, great finisher. This is it. If I divide this into 2 different columns, I apply the product law. So that's going to be log of AB, which equals to 2. Don't forget, that's base 10. AB is going to be 10 to the power of 2, or AB is going to be exactly 100. I'm going to put a box around that. I'm going to use this. Now, I'm thinking I could square both sides. Let's see if this is going to work. This is going to be A plus 2 root AB plus B, which equals to 64. Now, I kind of go back and I look at this number, and I can plug it in, right? So this is going to be A plus 2 times the square root of 100 plus B, which equals to 64. Now, if I think about this, A plus B equals to, now 2 times the square root of 100 is going to be 2 times 10, which is 20. 64 minus 20 is going to be 44. I'm going to put a box around that. Now, I think that's it. The hard part's over. You got this, everybody. There are a couple ways of looking at this. And I guess one approach is you can say A equals to 44 minus B. You don't have to use this exact method. I'm just going to show you one approach to avoid the paradox of choice. A becomes 44 minus B, and you multiply this by B, which equals to 100. Then we go back, that's going to be 44b minus b squared, which equals to 100. I bring it to the right, and this is going to be b squared minus 44b plus 100. And I would like you to press pause and solve this. When you press play again, I will be here. Welcome back, everybody. So I am thinking factoring. Doesn't look like it's going to work. I'm thinking about the quadratic formula. Again, negative b, which is negative 44, plus or minus b squared minus 4 times a times c divided by 2a. Now, I think I am going to use an approximation in this case because I have to solve for a again. And I hope I'm doing it right. I'm going to double check this one, everybody. Again, this is the beauty behind doing it in a live session. I'm just kind of doing it on the spot. I hope this is right. So now I go back, I grab the calculator. This is going to be 44 square minus 400. Take the square root. This is going to be, roughly speaking, 39.191835888 divided by 2. So this means there are two answers. And we got to figure out, do they actually work? Remember, there are restrictions that you want to think about. So I'm adding 44, divide that by 2. One answer is going to be 41.5959. The second answer is going to be 44 minus 39.191835888. Divide that by 2, and that's going to be 2.4041. That's the approximation. Now I got to go back and I say, well, A would be, again, 44 minus B. So in this second case, I guess, minus 44, this would be 41.5959. And in the first case, if I take 41.5959, subtracted from 44, I get the 2.4041. Okay, so it looks like these are very similar. And the question becomes, is this even right? All right, I'll double check with you. So if I'm doing it right, let's switch to a different color. I'm double checking. Oops, let's make this a little bit thicker. I'm double checking, right? So what I'm doing is I'm grabbing the calculator and I'm saying in the original, root A plus root B, like what does that equal to? So I'm going to try this. If I take the square root of 2.4041 square root plus 41.5959, but I'm going to take the square root of that. I do get approximately 8. So it looks like the first one makes sense. And, the second one's going to make sense as well. But if I look at the second condition, which is what? The log of A and B. So let's see if this makes sense. Log A plus log B. So I go back, I try log of 41.5959 plus log of 2.4041. This is going to be 2. Exactly. So it is my lucky day. Wow, I can't believe this works. Remember, your math skills are only as good as the last set of math homework. In the event that you need any math support, please do not hesitate to reach out to me. I'm only one email away. Thank you so much for listening. My name is Mr. Hung.